Welcome to 2.3 ions. We talked about atoms, talked about molecular structure. No, we have not. We talked about atoms and we talked about compounds. Now we're going to talk about ionic ionic stuff. Ion. It consists. I don't even know what I'm saying. Consists of ions and monatomic ions and polyatomic ions. So cations and anions I've already described. Cations are atoms with positive charge or less electrons, and anions are the negative charged ones with more electrons than they need. So ions that are atoms like that are called monatomic ions, right? So you recall that cations lose electrons and anions gain electrons, and that determines the charge. For example, a charge of 3 plus means the atom loses 3 electrons. So you take away negative 3, right? Basic math. So you lose 3 electrons, minus electrons give you a minus charge, so minus 3, which gets you 3 plus. So negative 3 plus means lost 3 electrons. And hydrogen, I'm skipping oxygen. Hydrogen plus means it's lost 1 electron. And most atoms can only actually form one type of ion. For example, hydrogen can never be a 1 minus, or 3 plus can only be a 1 plus. However, some atoms such as iron and copper and nickel can form 2 charges, 2 plus and 3 plus for iron, 2 plus and 4 plus for copper, and other ones I don't actually know. But in order to name the cation, you just state atom and cation. So iron cation, or sodium cation, or magnesium cation, or iron 2 cation, iron 3 cation, depending on the charge, the copper 4 cation. And in order to name the anion, just put "ide." So chloride, bromide, oxide, nitride, right? So we're going to talk about other ions later. So if you combine these two together, let's say iron oxide, for example, and you have the 2 plus charge, it's iron 2 oxide, right? So two ions come together, they're called ionic compounds. And ionic compounds, the formulas that say they're ionic compounds are ionic formulas, right? So in ionic formulas, the charges must balance. So let's do the examples right here. Balance the charges of salt and oxygen. And this handy graph right here, you can actually read. It's not a graph. It's a periodic table. It's an insult to call it a graph, right? So you can actually read how many what ions they form. So N, nitrogen forms 3 minus ions. They gain 3 electrons. Acetine gains 3 electrons. Chlorine gains 1 electron. Beryllium loses 2. So you've got to balance out this charge by having the number of atoms, right? So oxygen needs a 2 minus charge, produces a 2 minus charge. So oxygen gains 2 electrons. Where are they going to gain the electrons from? They have to gain them from sodium, right? But how much does sodium give in terms of electrons? It gives 1. So you need 2 sodium in order to combine them together to make disodium oxide or just sodium oxide, right? Okay, so now we're gonna combine these charges together. Ca, C2 plus, and Cl minus. Well, Ca gives 2 electrons away, and Cl takes 1 of them, so we need 2 of them to take 2 Cl to take 2 of them. So we have CaCl2, calcium chloride, Al3 plus and F minus, same thing, Al F3, aluminum fluoride or aluminium fluoride, and Al3 plus O2 minus. This might be a little hard, but aluminium has formed 3 plus cations, so 2 of them formed 6 plus charge, which means they give away 6 electrons. Oxygen takes 2 of them. So for every 2 aluminium, we need 3 oxygen. So Al2O3, right? Next. So some cations have 2 charges, right? So the Roman numeral suffix was written at the end of cation. I already told you, copper 3 oxide means the oxide has 2 minus charges, and the copper has 3 plus charges. So we only need 2 coppers and 3 oxygens, but copper is first, right? Copper has 3 plus charge, so it's named copper 3 oxide. So name these compounds: iron 2, oxygen 3, right? Oxygen has 2 minus charge, and iron has the oxygens have 2 minus charge in total. So the 3 oxygen has 6 minus charge, and iron has 3 plus charge. Iron will have 3 plus charge because 3 plus 3 is 6, and that 6 balances out the 6. So it'll be iron 3 oxide. Next we have gold and fluoride. Fluoride is 3, so it has a 1 minus charge, or just a minus charge, right? So 3 of them form a 3 minus charge, so we need 3 plus charge to counter that. So gold 3 fluoride. And the final one is just Fe and O. So O has a 2 minus charge, so Fe has to have a 2 plus charge, so iron 2 oxide. And as you can see, there's a gold right here. There's this gold. This is actually gold fluoride, and it's a crystal form. It's pretty interesting. I actually want to take the gold away from that. It actually looks really cool. Anyways, so ions can also be present as a compound, and these are called polyatomic ions. Right? Polyatomic ions are sometimes you hear them in acid and base names like sodium hydroxide or hydrochloric acid, hydrochloride. Those are all polyatomic ions, and by losing and gaining ions, they form acids. So nitrate exhibits a negative charge with only 3 oxygen and 1 nitrogen. Right? You can read this explanation, and it works for this, but it doesn't actually work for some of the other ones. Right? It doesn't work with nitrite, for example, and it still forms. Some common names of polyatomic ions are all of these. You should remember all of these. Right? I'm gonna be really honest with you. You should remember all of these, and I might link a Khan Academy down in the description. I probably won't though. For more that you should remember. Right? You should remember a lot of polyatomic ions. But some polyatomic ions you can actually quite nicely derive from other polyatomic ions. For example, fluorate right here, ClO3, right? If you follow this prefix-suffix rule, perchlorate has 1 more oxygen than chlorate. Chlorite has 1 less oxygen than chlorate. Hypochlorite, 1 less. Hydrochlorite, 1 less, right? So it keeps going 1 less, 1 less, 1 less. And if you go up, change the I to 8, it goes 1 more, and then add a per, it goes 1 more, right? And the naming systems, how many oxygens there are. So it's summarized right here. And name the other 4 polyatomic ions if sulfate is like this, right? So we have our SO4, SO5, 2 minus, which is per sulfate. I don't even know if that's an actual substance. SO3 2 minus. We have an SO2 2 minus, and then we have an SO2 minus. Right? This is sulfite. This is hyposulfite. And I'd assume that these are really reactive. The lower amount of oxygens there are, the more reactive they are. Hydrosulfite. Name the other 4 polyatomic ions if hyponitrite is NO minus. So we have N minus, just N minus. We have NO2 minus. We have NO3 minus, and then we have NO4 minus. And put the answers in the comments below. Right? These chemical formulas. Put the answers in comments below. I'll tell you in about 3 seconds. 3, 2, pause in the comments. Pause and answer the comments. Okay. So our first one is hyponitrite, obviously, and then we have hydronitrite, and then we have and we have nitrite, and we have nitrate, and then we have pernitrate. Right. Simple naming system. So the ions like this, they can just be combined just like normal elements in polyatomic ions. So for example, this is phosphate, and this is ammonium, I think. Yeah, this is ammonium, and this is phosphate. So ammonium phosphate would be a plus charge, so we need 3 plus charges to balance with 3 minus, so it'll be NH4 3 PO4, because we need the 3 plus charge, right? This is the same thing. Copper 3 plus. No, cobalt 3. Wait, yeah, cobalt 3 plus, and then 3 minus. We need from this nitrite, I think. Nitrite? Is it nitrite? Yeah, it's nitrite. Okay. So CO3 plus, and we need 3 minus from this, so we just do NO 3 minus 2. Oh, no. We can just remove the 3 plus and the 3 minus, NO2 3, and that's our cobalt nitrite. Right, that's a substance. I did not know that, actually. Number 7, oh my god. Okay, so I've been absent from this slide for so long. I made this so long ago that I didn't even know I give myself this much homework. Anyways, we're gonna be doing all of it. Okay, we're not gonna be doing 6. Not gonna be doing 6. Yeah. We're not gonna be doing 20. Right, so I'm gonna cross these 2 off because I don't want this video to last an eternity. Skip the charge of an atom when it forms an ion, and as you can see, we have this charge again, and you can always write the charges down, right? This is 1, this is 0, this is 2, 1 plus, 2 plus, 3 plus, and 4 plus. It could be 4 minus as well, 3 minus, 2 minus, and 1 minus, right? So K would be potassium 1 plus, oxygen 2 minus, and CO is cobalt. Where's cobalt? CO is cobalt. Cobalt can be no, cobalt actually has 1 charge only. It's 3 plus from the previous lesson. Ca is calcium, which is a 2 minus. No, a 2 plus. Iodine is a 1 minus. Iron is a 2 plus or a 3 plus. 3 plus. Gold, no, silver is, I think, a 2 plus or 3 plus. Gold is a 2 plus. No, gold is a 3 plus or I actually don't know. It's a 3 plus or something. Bromine is a 1 minus. The whole point of this exercise is to look at the periodic table, and you should be able to know which charge each thing forms. For example, astatine, At. I don't even know of astatine. Yeah, astatine, At, forms a 1 minus charge, right? So give the formula. We have a plus, we have 3 minus here, we need 3 plus to counter it. So we have salt 3, and then N3, no, that's it. Na3N, sodium nitrate, sodium nitride. We need a 2 minus to counter this, so we have copper iodide. We need okay, so there's a 3 and 2 ratio, so we have to multiply to the other side. It's just like the fractions that you do. So 1/3 plus 1/2 is something 6. So you need to form this, make it 6 as well. So that will be 2, and that will be 3, right? So then we need gold sulfide. Gold sulfide. Same thing here. We have Ca2 plus, and then NO3 minus, so we need 2 of these. We also need 2 of these. This will be calcium, calcium nitrate, calcium nitrite, calcium nitrate, calcium nitrite, and scandium. And this is a messy acetate. It's acetate. Okay, so this is acetate, and it's really messy. But we need 3 of them to counter scandium. So scandium, acetate, H3O2 3. Sodium, and that's sulfite, I think. Sodium sulfite. Yeah, that's sulfite. So no, not sodium. Silver. I'm sorry. So we need 2 silvers to counter. So we have silver sulfite. Silver sulfite. Next we have, I think that's either hydrocarbonate, hydrogen carbonate, right? So we have they actually balance each other perfectly. So hydrogen carbonate right there. We don't need the 2 minus on top here. When you combine these, they lose all their charges because the charges balance, right? So we need 3 of these, so that will be iron. I'm not gonna give the name; it takes too long. But I could say iron 3 chlorate, but that will take too long. So iron and chlorate, but we need 3 of them. That's it for today's episode. Actually, we have our final question. What is the difference between SO3 sulfate and SO3 2 minus sulfate ion? Right, one of them's an ion, the other one isn't. That's the difference. That's a simple difference. One of them's an ion and one of them isn't. And that's it. And that's the wrap up of all the ions. That's why I made you learn ions in the first place. That's it for today's episode. If you like it, press the like button. If you don't press the like button, and share if you think that what I am teaching is cool, and if you want to learn these fast lessons again, because I went through that pretty fast. Right? I think I went through it with enough detail for you to read the rest if you have time. But if you didn't have time, you can still study this for your final. But that's about it. See you next time for Lewis dot diagrams.